Today we will talk about circular motion, uniform circular motion, basically motion of the object, any object, let it be a point, and rotates around center, let it be the radius of this circle r, and the object, let's say car, moving with this trajectory, circular trajectory, with constant velocity. If its velocity is constant, we call it just uniform circular motion. Uniform circular motion means motion with constant velocity around fixed point, basically making a circle. So, since this is a motion with constant velocity, here we should be careful actually. This is not constant velocity. This is a constant speed. We should be very careful. Because velocity is a vector, it has a direction. Here, the magnitude of the velocity is constant, but direction is always changing. So this is not constant velocity, actually. This is a constant speed. We should be careful when you explain this kind of motion. So, speed is constant. Velocity is always changing. And since we have a motion with constant speed, we can use this equation. Distance equal to speed times time, because speed is constant. So, for one complete circle, what will be the distance? It will be the length of the circle, which is 2πr. Speed times time. And here, time needed for one complete circle, we call it, it has a special name, we call it period. And we use a new symbol, capital T. Capital T is a time needed to make one complete circle. So, be careful, this is important. This is not new equation as you see. This is not new formula. It's coming from our x equal to vt. 2πr equal to v times period. So from here, 2p times radius equal to speed times period. What is a 2p actually? 2p is the angle, 360 degrees. So when car makes one complete circle, basically it rotates 360 degrees. Yes? We can write it in terms of p and it's equal to 2p. Basically this is equal to 360 degrees in terms of degrees. So this is basically angle. Yes? Angle. So we can say angle theta times radius equal to speed times time. Times time. Again, this is not new formula. This is not new equation. Be careful. So let me take time to the left side. Let me take radius to the right side. So at the end, we will get this kind of equation. Angle divided by time equal to speed divided by radius. In physics, this expression, this formula, this equation has a spatial name. And we call it angular speed. And we denote it with omega. Angular speed equal to angle divided by time, or velocity speed divided by radius. Now, let me try to explain the meaning of the angular speed. Angular velocity, angular speed. So, let me choose this expression, angle divided by time equal to angular speed. So in daily life, we use degree to explain angle. 60 degrees, 90 degrees, 100 degrees, 180 degrees, 360 degrees. But when we solve the problems or when we write on the paper, we use different unit for angle. So as you know, any physical quantity may have some different units like kilometer, meter, millimeter, nanometer, etc. Same for the angle. Angle has different units. In daily life we use degree. But here in this equation we use radian. We use radian. In daily life we usually use degree. 60 degree, 20 degree. So it means there should be a relationship between radian and a degree. Because always when we solve the problems, we should use radian. Or let me say, it's easy to use radian. So relationship between radian degree is very simple. In order to remember it quickly, let me explain in this way. We know that in mass pi equal to 180 degrees. And also we have a pi equal to 3.14. Actually, this 2 pi is one physical quantity or one symbol, let's say. It has one meaning, just in two different units. The first one is given in terms of degree, 180 degrees. Second one is given in radian. So this is the radian. It means 180 degree actually equal to 3.14 radians. So let's say you have a 60 degrees. We need to convert it into the radian, so it's unknown. So this unknown actually equal to, here it's a proportion. We need to use proportion. 60 degrees times 314 divided by 180 degree. So from here, for example, answer will be approximately 1.04. 1.04. This is the same 60 degree, just in radian. In radian. So again, remember, we should use angle in radians always in this equation. In radians. So now let's come to the physical meaning of this angular speed. Before, let me explain the meaning of the speed. Equal to 3 meters per second. As you know, in 1 second, this object moves for 3 meters. This is the meaning of the speed. Now let's come to the angular speed. Angular speed, for example, equal to 3 radian over second. For example, it means in 1 second, this object rotates for 3 radian. And we know that radian is angle. So for example, 3 radian is equivalent to, it's approximately 180 degree, approximately. So in 1 second, this object rotates for 180 degrees approximately. So this is the meaning of the angular speed. So angular speed equal to 0, it means it's not rotating, it's not moving. If it's not equal to 0, it means it's moving and it's doing some circle. Now, let's continue our lesson. We said that here we have a constant speed. Velocity is not constant because it's rotating, because direction of the velocity is changing. Now, let's come to the acceleration. We know that acceleration equal to 0 if we have a constant speed, constant velocity. But here we don't have a constant velocity. Velocity is always changing. It means acceleration cannot be equal to 0. It cannot be equal to 0 because velocity is not constant anymore. It's rotating. So how we can calculate or how we can estimate this acceleration if it's not equal to 0? So somehow we should find this acceleration. I will explain here shortly. I will not give more details. I will just quickly write the equation. This acceleration, we call it centripetal acceleration. We call it centripetal acceleration. Sometimes in different books they may call it in different ways, but here I will call it as centripetal acceleration. Centripetal. What does mean centripetal? From here you can understand that direction of the acceleration shows or will be directed always to the center. So this is a center. We have an object moving in this direction, for example. Acceleration will be directed to the center. That's why we call it centripetal acceleration. And the equation for this acceleration, centripetal acceleration, A equal to velocity square divided by radius. So if you have a circular motion, that's all. You have a centripetal acceleration, and this centripetal acceleration equal to v square over radius. Speed square divided by radius. Direction, it will be always directed to the center. So for example, when it comes, this object when comes to this point, for example, it will be moving in this direction approximately, and the acceleration here will be directed to the center. A. Centripetal acceleration. Now we can write it in terms of, we can express it in terms of angular speed. We know that velocity equal to angular speed times radius. From here, angular velocity equal to angular speed times radius. So let me use this expression. So this speed equal to angular speed times radius square divided by radius. So from here we can also express angular speed in terms of angular acceleration in terms of angular speed, angular speed square times radius. So let me explain the meaning of this acceleration. You know, acceleration means force. It means we have a force directed to the center always. Without this force, this car or this object cannot change its direction. It will be moving straight to in this direction, for example. If you don't apply force downward, it cannot change its direction. If it's doing some circle, it means there is an external force. And this force causes centripetal acceleration.